suppose you're mostly aware of the fact that Red Hat 7 has been now released in its beta version and is now available for use, for downloads. We're going to have a look at the new features. There's quite a few of them, and that's why warranted perhaps as a separate session. Hopefully you're seeing my screen right now. This is just looking at the very basic installation of Red Hat. Hopefully you can see it at the moment. I'm going to open participants and chat so I can see any questions from you. And let's get started. We're going to look at various aspects of Red Hat 7. We'll be looking mostly from the technical perspective. Commercial side is beyond my expertise or want. What you're looking at right now is a vague list of topics rather than a precise content. Initially, we'll just have a look at the architectures and where Red Hat 7 is aiming, but we'll follow it with looking at the administrative side, the developers, and so on. I've spent a little bit more time on those features that are perhaps totally new to some of you, and that may be the service management and some of the container and other aspects of administration. Just for completeness, because it's a new product, a lot of the information that I've collated for us here for this session comes from various sites. A lot of it comes from Red Hat themselves, but some of the other announcements, some of the other techies have been already playing with it and posting comments. So unashamedly, I have pinched quite a lot of information from various sites. I will, of course, make sure that everything is attributed to all the sources correctly, partly, of course, for legal reasons, partly for you to be able to follow this session with looking perhaps at the same sources. And as I say on this main slide here, anything that is quoted further down within the presentation and not directly explicitly attributed to anybody will have come from Red Hat's release notes, either main release notes or there is alongside the beta release notes, there's also technical release notes where they posted some of the technical issues and comments. And initially, if we just look at what's happening here for when it's available, the subscription or a little bit of business side of it, and also where it's aimed in terms of technical platforms. The beta went available at the end of last year. It can be downloaded by just about anybody. You can download it self-support. You have got the 30-day evaluation copy. But of course, anybody who's got any current subscription can download it and based on that. Red Hat are being very bold with their statements as to the future plans for this release. We believe it's our most ambitious release to date, and mostly because they are integrating a number of technologies which are emerging technologies or would be called as emerging technologies right now, all the way down from the kernel, all the way up the stack of the software, all the way up and pushing it into the cloud. There is a clear path that they are envisaging with this. In a couple of, I'm not actually very conversant with the detailed models of subscription. It's just to get it out of the way. They are changing the subscription management model. The Red Hat Network Classic is being replaced with a new model of it. I'm not going to read the detail of what's what, but of the migration of our application, you can look it up. Just be aware that there is that new model. There is a command line tool for managing your subscriptions, and again, I've played with it. You don't need GUI, in other words, or you can start GUI if you want to. I'm not going to dwell too much on that. Back to more perhaps interesting, or let's start more interesting aspects of the discussion. One important difference in this planned release of Red Hat that I noticed is the fact that it's going to be a lot more up-to-date than it used to be. We, with Red Hat, kind of got used to the idea that both the kernel and the platform, the operating system and the applications, sometimes several years behind the leaders. As it is, Red Hat 7 is going to be a lot more contemporary and up-to-date. So first of all, they based it on Fedora 19. I'm not entirely sure, but I think Fedora is running on 20, so that is as new as it gets. It also gets one of the contemporary kernels, the 3.10, is a massive jump when compared with the predecessors. I think, and as far as RHEL 6 is concerned, I'm on the 6.3 and it's using kernel 2.6, quite a low one, 30 or thereabouts. So that is quite a massive shift in approach on Red Hat behalf. We will have a closer look at some of the differences, but it is many subsystems have changed quite dramatically, and I suppose by far the most significant aspect of that is the implementation or uptake on the System D mechanism that is going to replace the traditional RC run level style or the later upstart. We'll have a chat about that. But some of the other file system networking and containers and all that kind of stuff, we'll have a look at that as we go along. 32-bit for corporate environments, basically forget it. I suppose the assumption is that you wouldn't be putting RHEL servers on 32-bit machines anymore. So it's targeting 64 bits with a variation on the theme, IBM Power 7, Power 8, IBM System Z as well. So it's quite a selection there in that respect. You do have 32-bit, the binaries will run, and you still can run 32-bit as a guest. But no, you can't put it on the main machine. I'm not going to go through detail of the limitations, but we are in a really high availability clustering supercomputer world here near enough. We've got the over 5,000 logical CPUs or cores. That is quite massive. Scaling up capabilities, going up to 64 terabyte memory. That is not going to limit you right now, although we still the certification from Red Hat is up to 3 terabytes, and with 1 gig per logical CPU. So it's now we will have a chat in a moment when we talk about file systems. We will mention again, or we will look again at the fact that the main file system type in RHEL 7 has been replaced. Red Hat are going away from EXT, from extended file systems, and the main default one is XFS. The others are still available. We'll have a chat, as I said, again. But the use of the XFS as the main file system type now defined the maximum file system to 500 terabytes. And the maximum file size to 16 terabytes. These are massive values. And the theory behind the file system, if you can see there in exabytes, that's mind-blowing for operation of normal average servers right now. And yeah, I'm just looking here, just very briefly, if there are any questions. What is the limit of maximum number of files which can be created in XFS? Don't know the offhand. I have got, it is stated in the release notes. I have not made a copy of that. I will have a look at and I'll answer it later on. Okay, so we will come back to that as we go. I'll answer Syed. Oh, Syed, I think I can recognize the name. I'll come back to this. As far as so it's relatively random choice of topics that I'm going to be looking at. And it's mostly to make sure that we have ability to distinguish it, to contrast it with previous versions. So it's not a full system sysadmin course. If we just look initially, before we get the system going, during the installation process, Anaconda is still the installation program that is going to be running there. It's claimed that it's been updated and certainly does look, Fedora-like, it certainly does look totally different. And the whole purpose of it, the main purpose of it, is to speed up the installation itself. We've got a lot of parallel operations going on when the installation process starts. In other words, when the disk gets formatted and then the disk gets installed, at the same time we can continue with the conversation with Anaconda and continue configuring other aspects of the installation that we're putting on. So the parallel operations are certainly helping there. If you can briefly see on the screenshot attached to that slide, is that the main elements of installation are configured, can be configured in any order independently of each other. You can come back to some of them, you can leave them off altogether and configure after installation. So it's certainly a lot more flexible, and the customization side of it is quite good. The fact that you can skip the installation, if I'm sure that is interesting, although some of them you have to, of course, the disk and so on. Another initial startup issue here is that having refused to move to GRUB2, RHEL now use GRUB2 as well. It has been expected for a while, although there was quite a lot of controversy there. Some people saying GRUB2 is still not stable, never declared stable. But yeah, in the end, original GRUB had never been formally announced as stable anyway. So that argument didn't, of course, carry on for too long. We do have, with Red Hat adopting GRUB2, one advantage of it moving to this level is that all major distributions now use GRUB2, where we frequently criticize distributors for not talking to each other and going their own way and pushing their own way. This is one area now that everything's converging, and we might as well start learning it properly. It does, if GRUB2 certainly is more powerful than the predecessors with a GRUB, which they now call GRUB Legacy or even Lilo, in that it can understand all modern technologies and firmware levels. Of course, a very important aspect of that is the UEFI capability of doing the partition on the GUID. It does understand the alien, we could say, file system type. So apart from the Linux file systems, the partition type 8.3, it now can work with Macs and Microsoft file system types as well. For sysadmin people, they're major, if you've never touched GRUB, if you've never seen GRUB2 before, the major issue is that configuration is totally different. The menu.lst file that we had is no longer there. So instead of having individual stanzas in that configuration file, we now need to explore the files allocated to each operating system that you want to boot, and those files are under etc. There is grub.configuration file CFG under boot directory as it used to be, but its content is different. But if I pop out of this and see if we can have a little demo, I've got a, let me just log in here. I've got a basic installation of a RHEL 7 running in VM here. It's not a full-blown server, so not everything that can be demonstrated, but just to show a few very basic facts about the system before we move on with the further stuff. As always, those of you that know me probably suspect that whenever interrogating the system, the first thing I do is go into proc. Proc is something that can give me a lot of information about what's happening in front of me. And so some of the files that I would be exploring here is the version. For those of you who perhaps are not familiar with proc, this is a location in Linux that the kernel maintains dynamically, and that reflects the state of the system, the hardware, the kernel, and it's the most up-to-date and most reliable information about the system. Admin people will be interested in seeing the Linux version. Developers might be interested in seeing 4.8.2 version of the GCC compiler. We will mention, by the way, do bear in mind we are looking at beta, so when the main release comes out, there might be slight differences. And next typical stuff that I would be looking is what kernel vocabulary is used and what parameter it would have been started with, but we won't go into too much detail, of course, here. Another stuff, what are the file system available to me? And of course here, the one that we've already mentioned, the file system available, the main file system is XFS. As I said, we will have a chat about it as we go along. There is a couple of, there's quite a few that we could be exploring. I'm not going to be modules. I'm not going to be spending too much time, of course, because time is limited here. What modules have been compiled in addition to the monolithic kernel that we have? That very often conveys an awful lot of information about your system, about your hardware, and about the intention of how the system was put together. I will also show one more little file that I'm not going to be discussing in detail at this point, but we will come back to this as we go through the session. And that is the fact that the kernel now will come or comes from Red Hat pre-configured for control groups, and they will play quite a big role in both service management and discussion of the quick chat we'll have about containers, or the method of almost virtualization that will be used here. Okay, so having looked at what the system is, there is a couple of interesting points that I might point out at this early stage, although again, we'll pick up on the discussion later on. I'm basically going through steps that I apply every time I look at any new machine, trying to get my head around what I'm looking at and how it varies, how it differs from anything else I might have seen in the past. And looking at init tab file, anybody who's coming from the old version of Linux or Unix world would be familiar with that file. It existed for 40 years in every version of Unix, and it's on its way out. In a way, we could say it is out. In Linux, it's no longer playing any role. We'll look at this again later on. Other than that, I think that's mostly done that. So I will pick up where I left off, and that is looking briefly at the content of the boot directory. You might be aware that the /boot in Linux contains your kernel or kernels that you might want to have and have available, and all associated files that your kernels would be using. Amongst things, so we are actually seeing the normal standard instances of the main kernel and the rescue image of it and all the other RAM disks and stuff. It's this GRUB thing that I wanted to point out. We now have, notice, no menu.lst, but if I look into the GRUB2 directory, we've got quite a lot of stuff here. And we've got GRUB configuration by CFG file, which vaguely, very loosely could be described as a replacement to menu.lst. And I do emphasize very loosely because this file is never configured manually by us. This file is generated, this value is generated automatically. You will notice that I use sudo rather than switching to root, and that is because forgot the command there, talking and typing. And that is because I'm a big advocate of using sudo or role-based privileges rather than blank root application. So even though I kind of have expected Red Hat perhaps dropping password for user root and going full-blown sudo application, just like Ubuntu do. I always liked that about Ubuntu. It appears they haven't gone this way. So you still have password for user root, but of course you can apply sudo if you wish. And going back to the file here, this is the configuration for GRUB. Very big warning at the top, you do not edit this file manually. You adjust your settings in the etc GRUB directory, and you've got the default directives for GRUB behavior separately under etc default. It's beyond the scope or time for me to go in detail how GRUB 2 is configured. It is a quite a learning exercise if you've never seen it before, but it's something we'll have to go through, no doubt, all of us. Okay, and I'm just briefly checking, so it's still there's no other questions there. So if we go back to slides. And I did mention that XFS is installed by Anaconda by default. We do have I still have to look up precisely how many files can be created in XFS. That question that was from a panelist. My feeling is that unless you're dealing with really massive high availability storage environment, for a normal sysadmin, the answer would be unlimited. I'm sure there is a number there, and we'll look it up. Because the scalability of XFS is massive. It's a journaling, it's high performance. By the way, it's nothing new. Somebody is helping me. Okay, the same person. It was 32,000 per directory in ext3, 64,000 per directory in ext4. Okay. And if the XFS, application of XFS, it's actually nothing new in the Unix world. XFS is quite an old, I'd say 20-year-old file system type, used in Unix, used in IRIX in the past, and it's been now adapted and adopted by Linux as well. And one of the advantages of that is because it's so well geared towards fast, efficient, reliable, and self-preparing file systems using Pedigree, and it's a really very powerful file system type. In a way, it's another example, another instance where technologies are converging. It actually is, rather than being fragmented further and further, we're going back to the roots, improving it and using it again. We do have other file system types still supported. So although XFS is the default one that Anaconda will apply if you don't tell it otherwise, we also have the still continuing support for ext4. With increase, you can see a couple of parameters that stated on the slides. With increased capabilities, we also now have a B-tree file system type from Oracle, BTRFS. It's now included after a lot of hesitation in the Linux part. Within the kernel, it was available for quite a while. but no main distributor included as a default yet. With Red Hat providing it, I'm sure it will give it a good springboard for developers to test and start implementing it. There is a interesting omission of RISE-RFS mention, it's not even mentioned anywhere, let alone being supported or included. So that's traditional, one of the traditional Linux file system types looks like is going to become legacy soon. And once you start working with XFS, because it's a totally unique file, not because it hasn't originated from the Linux world, it is a powerful, it's got a totally new set of tools that comes with it. Again, old-fashioned Unix people are going to be quite at home with it, I suppose. And it does have all sorts of sophisticated capabilities, like quotas, both users, both groups and process classes, 3 types of quotas available. It does have a snapshot, although not in the same sense as you may understand a snapshot. Snapshot here is done through freezing the I/O operations, taking the snapshot and then opening the I/O again. Snapshot is done through LVM. There is no inherent snapshotting capabilities within the file system type. XFS is meant to work in conjunction with logic volume management, and within Linux it will be LVM2 currently used that you would be applying it to. As you can see, you can resize the XFS file system on the fly, although my understanding, my belief is that you can only extend on the fly, you can't shrink it. But if other than that, you can manipulate, you can back up, you can do an awful lot of it on the fly with the file system active, mounted, and being used. A couple of other points. So that was the main difference in file system. A couple of other points as far as administrators are concerned. If actually before, if I may, to freeze this, freeze, no pun intended, one little more comment about XFS, something that was concerning me initially, because I am a big fan of extended attributes of file systems, so ACL, and that is available out of the box with XFS, so that's no problem. But one of those extended attributes that I always in Linux use is the chat. I wonder if you may be familiar with that. There is an additional set of attributes you can apply to a file for the purpose of making a file immutable or change the access permission to it in a more granular and non-standard way. And that is, for me, for example, the ability to be able to change attributes specifically for the purpose of switching immutable attribute on a file. And that could be something like host file, where you want to perhaps ensure that once you've configured the host file, nobody can modify it. If you're familiar with immutable aspect of a file system, file that is declared as immutable cannot be modified, cannot be removed, not even by administrator, cannot even be linked to. So it basically, its status is frozen. The only thing you can do with that file is read it. And the ability of apply those immutable bits to selected files, those that you don't want to meddle with, is something that is very useful indeed. Yes, I am running XFS file system, and in fact, that was one of the first things that I checked when XFS came out. Can I apply immutable bits? Now, and of course, if I look, that was not a surprise, and I did expect that yes, ACL is automatically applied to everything. Host file doesn't have specific ACL applied. I just use get at ACL just to see that the capability is there. And if I so wished, I could apply the extended permissions there. Okay, so that was just this slight more conversation about or discussion about the XFS specifically. I nearly had moved on talking about networking. The basic networking in Red Hat 7 is not being changed dramatically. To my best knowledge, we still use the same set of configuration files, same location, same main mechanism. There's a couple of changes, and the most significant change is that we now have this notion of consistent device naming for network interface cards. The point is that rather than having ETH 0, 1, 2 forever assigned almost arbitrarily, we now have the consistent naming. It appeared in Fedora, apparently in Fedora 16, and we now use it here in RHEL 7. Names are assigned according to card physical location, and it really is a very specific sequence of checks that the daemon will do in order to allocate the name, and it will pick up information from the BIOS, from the firmware, first of all from embedded devices or onboard devices. You can see the type of names that will be allocated to there. PCI slot number might be part of the allocation of the name as well. The location of the connector, this would be for serial, for modems, what we used to know as TTY as zeros. You might have the interface MAC address as part of the card num, and if any of those checks and allocation methods fail or not possible, then you may end up with a traditional ETH or WLAN as we've had up until now. So those checks are done in a very particular order. In the previous slide, if I can pop back to the previous slide, it does state in the release notes of in one of the documents somewhere that if you still have those persistent rule files under UDEV control, then yes, you can force. If your installation, if your setup does demand that you use a particular naming convention for your network interface cards, yes, you can override it, and you can hardwire it, as it were, into the networks. Now, I've got mixed feelings about this. I do recognize that having consistent naming based on your hardware, location, and your topology is very useful and very practical, perhaps. And it certainly will overcome the problems we had with those names that we decide according to MAC addresses, and then that hardwired and persistent rules file when we moved it in the VM. So when you installed the system and took a VM out of it, moved the VM onto a different host, VM host, and then we had problems with ETH 0, 1, 2 popping left, right, and center. So certainly the consistent device naming is going to overcome that and might make our lives easier, even though it might take time for us to get used to those new names. Shouldn't be a big deal, though. That's about the only main new issue or difference or aspect of the networking that I have noticed. There is quite a lot of, in terms of services and in terms of applications and tools, there's been quite a few announcements regarding that. As far as databases are concerned, Red Hat will now provide and support the new of them is MariaDB, which you may be aware of. It's a fork of MySQL. It's quite his number. I notice there's a little bit of theme showing through some of the software choices that RHEL 7 made, and that is an independence of software, or attempt to be independent of software generated by Oracle. But Maria is one of those instances here. MySQL will be provided as will be the PostgreSQL. I'm not quoting the numbers here. You can see the numbers, and you can see that Maria is actually a same level fork of MySQL that is currently provided. The web server is still Apache. There's nothing new here. Open LDAP, so all that stuff is mostly unchanged. Network manager, well, anybody who's been on any of my courses will know what I think of network manager. I never understood its purpose for servers. I can see how indispensable it can be, and indeed is on laptops when you need to have wireless discovery protocols. But on the server, I could never understand why it always interferes with the configuration and the network daemon, main network daemon. Typically, I tend to switch it off and do away with it. It's still here. I found it, maybe I don't understand something there, but I found it rather bemusing that it's stated now in the release note that it's been improved to make it more suitable for use in server applications. Well, I'm failing to see how I would want to use it in server applications, but again, I might not realize that some specific config. There is a new tool created for that. I have played with it, and I suppose that's all I'm going to say. I have played with it. It's considering that Network Manager was switched off almost immediately thereafter, then it didn't last very long. Yes, you can switch and stop. Notice I'm not going to describe it closer here, but do notice no mention of service command, no mention of check config command on this slide. To stop and switch off the services, we now have a totally new tool. We'll come back to it later. systemctl. This is how you would switch it off. In the standard daemon, you would start with the same command, enable and start. That is normally started anyway. So typically, if you're installing a GUI especially, you would have both of these services running alongside of each other. Whether you use it or not, you probably might have a better idea how important it is to you. Can you show an example of the device name from the command line, please? That's the question on the chat. I take it, because we are talking about networking, I take it the device name. That's actually a very good point, because I haven't looked, which means if I say show me device names using IP command, oh, that's interesting. That it looks almost, it's picked up from, that's interesting. That number, is it partially MAC number? Not sure, no, that will be PCI. PCI is some form of number. That's the name that was assigned dynamically. Okay, so I hope this answers. Somebody else says it is recommended to keep it on. Presumably Network Manager. Presumably Network Manager. Somebody says it is recommended to keep it on. Fair enough. Fair enough. I'm not gonna argue. As a general point, I certainly wouldn't recommend start going because somebody said it's no good, take services away. you would only do this based on your situation and knowledge. I'm just looking if there are any other questions related to that. No. If we move on, therefore, to software discussion, again, trying to keep it within the scheme of things, as it were. There's a lot of detail here, but a lot of just version numbers and levels. To those of you that are involved in development, it might be quite useful just to know what's available. First of all, I had a quick look at it and play with it. Yum is still the update manager. I had actually problems updating based on my subscription. It's a fully paid up subscription, but in fact, I've got a support call going on with Red Hat at the moment because I wasn't able to add any software. Which means, unfortunately, that the level of Yum operation I wasn't able to test fully. But it's okay. It shouldn't be. I don't think there is any major difference there at all. The standard of repositories. You can see the default configuration of repositories. There is an ePO repository available for RHEL 7, and they're a lot more open to external software. We'll have a chat about one of the products in a moment. Currently, updates for beta are not yet available, and I actually suspect that my problem with some of the software installation is due to that. Now, we're not going to spend too much time for desktops, concentrating more on servers. Desktops are available. You may have seen the splash screen on screen on my installation. Looks somewhat different because we now have GNOME 3. We've got a choice of KGE4. Those Plasma workspaces, case screen, they're kind of GNOME boxes. They mean very little to me. I don't operate in GNOME on server, so I'm not quite sure how useful it is to you. As far as the desktop software, it is LibreOffice. That's interesting. I actually used it. I use it for the purpose of opening a .pub file. My other half got a document, insurance policy from somewhere that was sent to him by email with the .pub extension. None of his Windows at work or anywhere machines were able to open it. We Googled it, we realized that it was a publisher application, and without it you can't open. And guess what? LibreOffice opened it. And so that was quite a success story for showing that perhaps there is something in Linux even desktops. GIMP for photo processing, all multimedia programs, which means yes, you can have a fully blown working desktop out of those 7. And that's about it. I'm not going to really dwell on it too much any further. As far as developers are concerned, there is upped versions on just about all of the elements of development. You've got the GCC 4.8 release that is now basis for quite a lot of other libraries, and toolchain, GC toolchain. You've got the GDB debugger version there as well. There's quite a list of performance tools that they're advertising there. And in fact, I had a play with a Copilot, and that is quite interesting. I've got no prior experience of that, so it was just playing for this, and I quite enjoyed playing with this. Looks like it's quite configurable, and for developers could provide quite a useful benchmarking tool for that. And we've got standard, nothing terribly new or exciting here. We've got CVS, SVN, and Git provided for version control and calibration, perhaps. GitHub, of course, would be useful, a lot of things. In terms of scripting languages, basic languages there, we've got, we say, old favorites there. 4.2 Bash, we've got Python, we've got Perl, Perl 5.16, no Perl 6, not surprised there, no surprise there. But what was surprising is to find that Ruby is now one of the mainstream languages that Red Hat providing, and with a new interpreter, which is actually quite good news for one of my colleagues who is currently writing a Ruby course, training course for us. So he will be pleased to know that it made its way, the language made its way into the mainstream of languages. If somebody is saying, if you forgive me, I'm reading the chat. I imagine you will show what is now used instead of check config and service commands. Yes, indeed, I will. We will have a chat about systemd, leaving it as almost a separate portion of the presentation. So yes, we'll come back to that. Somebody else, LibreOffice in RHEL 6 was on the workstation only, wasn't it? I have failed to find it on the server DVD ISOs. Indeed, that shouldn't be too surprising because servers now come without GUI, and of course you need GUI for LibreOffice. So the GUI version, the non-GUI version, server version, would never normally have it. Yeah. But that's the main Office application now. Moving on, Eclipse is the developer toolset. There is that interesting comment I came up. I wasn't able to verify that, but apparently you won't find Eclipse in their main repositories now. You need to have a developer toolset in order to get that. As I say, I haven't been able to verify that. You'd have to have a look at it. But that's the new aspect, or at least new to me, is the fact that you now have a completely separate set of software known as Red Hat software collections. I believe it was available in the past, but not formally supported by Red Hat. It now is, and that means that you can, through your subscription, you can access it, and you can see there that you effectively have two strands of software available to you. One with a long-term 10-year support that you can base your stable products on, but you also have the new releases. Effectively, to me, it feels like Red Hat are giving to Red Hat customers much closer coupling and availability of toolsets and products available to Fedora. So you have that peek ahead capability within the mainstream Red Hat rather than having to run a separate Fedora machine and experiment there. And that, I suppose, should increase because, of course, if you have to go away from the main Red Hat to develop something and you only can do it in Fedora, you are still working in a different, you are definitely working in a different environment, different potentially libraries, different kernel, different external interfaces. So to be able to test and run stuff with the latest version of packages and software available should certainly be advantageous to developers. That software collection is a product, and the one example that's pointing out here is if I go back a couple of slides, the Python 2.7.5 is installed by default, provided by default during the main installation. You go to software collections, and you will have Python 3.3 available from there. Notice that the release cycle is different, and from 10 years to 3 years support, that's a minor release of 9 months. Every 9 months, that is quite a frequent step. And just looking whether there is any other note. So that was just a rundown, hopefully sufficient to get your feel for what it's going to provide for developers. And Service control, this is where I'm going to be talking about the new methods, the replacement for traditional SVR4 staff RC command and the upstart that was the Linux replacement to it. It's of course part of the sysadmin job, so should really belong to the previous, but it's substantial enough to go as a separate little topic. I'm going to mention an aspect of the kernel that is absolutely crucial to the success of not just systemd, but some of the other development as well. And that is the so-called kernel C groups. C groups is a feature of the kernel that has been in existence for quite a long time, a very long time, but very few applications or technologies were making a proper full use of it so far. And again, it looks like Red Hat are basing an awful lot of their products around the capabilities that the C groups provide. And one of those capabilities is the new control mechanism for starting and shutting the services, and that's the systemd daemon. We'll look at that, and at the end of the discussion, theoretical discussion, we'll have a quick demo of it just to see how it all works. Very briefly, C group is a kernel capability, and a C group allows you to itemize, tokenize, and group and collect resources at the kernel level. And if you can even see it through the standard PS command with some of the allocations. And the whole point is that you can both limit and allocate resources. And that allows for grouping of processes for a variety of purposes. That is what allows you or allows the developers to parallelize startup of services, running services concurrently, or starting them and shutting them. This also allows creating zones or containers, in other words, grouping processes and running them independently of each other, those groups independently of each other. This is, and that container stuff we'll mention again as we go along. There is a notion of controllers. Controllers are elements of the kernel that manage C groups, allow you to put resources, deny, control, put a limit, and so on. We also, of course, will have user space tools to make use of that. There is a very interesting, at Oracle, a very interesting article about that, and so you've got the link there at the top, which it very clearly identifies the C groups for the two very fundamental purposes. The ability to organize processes hierarchically and name them and label them together. So grouping, collating, hierarchically or arranged processes. It's the notion of parent-child relationship is there, and we're not going million miles away from that. It's just how we collect them, how we group them, and how we name them. And the second purpose, or second ability that C groups allow us to achieve, is to manipulate those groups of processes. And that can be done for a variety of purposes. As far as the startup and shutdown is concerned, in other words, as far as systemd is concerned, we are only making use here of this hierarchical group collection and naming and labeling. Okay? And there's also some container stuff we'll discuss later on. Very briefly, you may recall, this is looking at those two elements. I haven't switched this side, walking and talking to myself. Very briefly at the beginning, during the first demo, when I changed into proc and we looked at a variety of aspects there, we looked also at the file called C groups. And that is an indication that by default, number of those groups are created by the kernel for us during the installation. These are the kind of groups, that subsystem name that we have. On the right-hand side as well, you need to have the elements of the kernel enabled for the C groups to be able to be utilized. And we've got two types of directories. First of all, we've got the config groups switched to yes permanently. That is absolutely essential, whether we want to make use of C groups for systemd purposes or containers or zones later on. We also have a number of so-called controllers, or those elements of the kernel that will be used in the zones, but are not necessary for systemd. In other words, what I'm saying, although by default they all come switched on, you can see it's all yes, 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 all those controllers. And in reality, if you don't want to use any virtualization aspects, any containers aspects of the kernel, you could switch them off. You could remove those attributes. Again, I'm very aware to make sure that you don't read it as I advise you to switch it off. Never ever modify anything that the system gave you by default unless you know exactly why you're doing it, what the purpose of it is. This is here just to state that in the context of the current discussion, we do not need those controllers. I'm just seeing here another question. Is ulimit a user space tool for it? Ulimit is I haven't actually tested it in the in RHEL 7, but ulimit is a shell built-in tool, and it's got in effect nothing to do with the kernel configuration or C groups configuration. This is almost voluntary. Ulimit is a voluntary mechanism whereby users can control the amount of resources that their processes would be consuming. So ulimit is a user space layer on top of anything that we are discussing and not directly related to it at all. Going back to systemd, just to recap what I've been saying, it is a replacement for RC and upstart. I suppose I might go away and have a slight diversion and discussion my comments. I always had the issue of different distributions going their own way and doing their own thing, and the poor sysadmin sitting there and having to learn all of that. This time systemd is introducing again unification. Red Hat is the last major distributor to adopt this. Therefore, SUSE, Ubuntu, Red Hat, and a number of other distributors are using it as well. Ubuntu was very reluctant because, of course, Ubuntu were recommending upstart, but it was Debian people in the end. They had a vote amongst the developers there, and when Debian decided to go systemd way, Ubuntu, Mr. Shuttleworth, had to give in and go that way as well. With Red Hat now going that way, at least definite one massive advantage that this will bring. We've got one technology to learn, we've got one technology to script. Our programming, our scripts will be that much more portable. There is a lot of controversy, and amongst those people that are skeptical, if not critical, some of the top developers of the kernel and involved in Linux. And the criticism is that systemd is meant to be a tool controlling absolutely all system resources. This is not just for services, this is for sockets and all sorts of other stuff that we'll refer to as units in a moment. In other words, it's got a fantastic potential for bloating, for being bloated. It's got fantastic potential for being very complex and very difficult to control. It also means that everybody needs to reskill, and for some of us who are who've been playing this game for a little while, starting totally from scratch might feel a bit alien, and I'm certainly one of those people. But I must say, having been very critical of the concept myself, having played with it for a while, I'm warming up to it. And in fact, more and more I'm playing with it, more and more I'm finding it as the similar, although totally different technology, but similar sentiment that Solaris adopted with their service control. We certainly have a lot more dependency capabilities here. We certainly have a lot more potential performance advantages here. Again, because we are making use of C groups, we are having better and better ability to do things in parallel. Just to recap, yes, you do need you're making use of the hierarchical ability to store number of processes under common label, and we only need the config C groups parameter in the kernel switched on. We do not need other controllers for that purpose. Now, one of the major advantages of systemd is that we have an element of dependency definition. If you recall RC scripts, there was none of that. Everything was done based on you knowing which number to assign to a link, script link. In Upstart, there was an attempt of event-driven service control. I never warmed up to Upstart. I could never get a hang of the dependency definitions there. Who's going to start what? It does seem to me that systemd is going to have the dependency defined clearer and better. And I'll show in a moment, very briefly, where we can find things. The run level idea, although run level command or who-r command still work and still give a same result or same output, will show you which mode of operation you're currently in. The run level concept, however, is now replaced with an idea of so-called target. And that, in fact, is very, very closely resembling what Solaris are doing when they talk about milestones. Instead of having one or two different run levels or modes of operation, single user or multi-user, and a couple of those, we can now define with very, very good granularity what we want to have running when the system goes up. If I want a LAMP server, I can have my own target that will have a particular network features running, and I'm only switching Apache and database and PHP or whatever. And that will become a run level in its own right. So the ability to be able to do that granularity is definitely a big advantage. We have a better dependency flow of service life. I will show in a moment. When we look at the example of a script, you will see what's happening. And the power efficient, reliable manner of controlling other devices and sockets and systems. That I'm yet, I'm not disputing that at all. I just haven't had an experience of that to be able to perhaps explain deeper. Entities under systemd control are known as units. I think that's again a very interesting, in my mind, personal comparison with what Solaris are doing. Solaris is using an awful lot of XML and almost object-oriented vocabulary there. Here they were trying to reinvent just so that it's perhaps unique and not confused with any other mechanism. Unit is an entity, is anything, is an object. It could be absolutely anything you can think of. Just looking at the manual pages, what units are available, you can see there the service is fundamentally what we have started to discuss here. But we've got sockets and it's a target unit, and that will be interesting if you remember target being an equivalent or replacement to run level. The devices mount units, a lot of automating, a lot of file system operations will be done through unit. There is a snapshotting, there is swapping path. Some of them I'm not yet fully familiar with. Is there a limit in targets? I'm not sure I understand the question. Are you saying is there a limit of how many targets you can have or what you do? Okay, in that case, trying not to be authoritative here, I do not believe there is a limit on number of targets you can have. Okay, because it's all user definable, because you can create your own scripts for that, your own files or text files we'll see. I'm sure you can define an arbitrary number of your own targets. If we now look at what's happening, this is in fact, I'm gonna switch over to a demo and see if I can show you, starting with looking at init sub file as well. So we'll look at, and have a starting point as that. If I look at /etc/init and the reason why you're looking at that, we have already established that the init tab file is useless. It's no longer used. Unlike in Ubuntu, where Ubuntu abandoned, it doesn't exist at all whatsoever. Here we still have a file, but they're all comments. And the comments are quite useful. You can see straight away where configuration of stuff is, /etc/systemd. And you can see their approach. Multi-user is analogous to run level 3. Graphical target is analogous to run level 5. And that is the guts of the matter. They also show you, you may recall that the last few editions of Red Hat stopped using init tab in its original form, but it was used purely for the purpose of defining the default run level that the system would go into when you start up the machine. That line is missing from here as well, but at least they left a message behind for you how to achieve it. If you want, the default machine that I installed came with GUI. If I wanted to convert it into more server-like mode of operation, and if I wanted to say from now on, I want to see just the, I don't want to GUI next time I boot, this, I would have to link that file again, and I'll show you in a second. Therefore, in fact, let's move on to show you that. If I list the content of /lib/systemd and system, you will notice that in here I've got tons and tons of files. They're all text files, they're all readable. And the two main groups that you can identify is the service and the target. Okay, target is your destination, is where you want to end up with. It's your ultimate mode of operation that you want to end in, and the service is the description of what it does. So if we have a quick look, they're very much init style from Windows files. I'm just going to multi-user target, and just to see the layout of it. Multi-user dash user. Did I do? Yeah, I haven't changed there. My apologies, guys. I did not change there. I just listed. So if I change there, and I can now have a look at, hopefully it will work better. Yeah. It's actually a tiny little one. All it says, notice the sections, unit, and install. There is a description, there is a documentation, and this is an example here of dependency description. Okay, it tells you what other target I need to go into. When a moment ago I replied to the is there a limit in targets, and I said I believe no. It's because the target can lead or can be a step on reaching another target. So the target can be arrived at and then moved on to the next one. And clearly here, the target going into multi-user describes first, as the first prerequisite step, going through a basic target. If I now want to do check what's going to be happening in the basic target, I'll have to look at that file first. But it shows also conflicts after and the sequencing a little bit, allow isolate. I'm not entirely familiar with all of them. Alias default target, that's an interesting thing because we'll come back to this in a moment. So we'll have a look at a couple of others, NFS, for example. And if I'm being totally honest with you guys, I have played with quite a lot of this, but I have certainly not seen a number of those as yet. And I'm looking at NFS target for the first time. So I'm not sure what to expect. Description is, yes, what I expected. It's a network file system. And what it's saying, these are what's required. So I've got what the dependency is that mount required, is the proc mount required, and our CPU bind service required. And when I've done the NFS, sorry, I will do it after the network target main service routine. So it's not only prerequisites are defined, it also a sequence of events which is defined here. That definitely beats the basic RC scriptability of sequencing stuff. And it definitely is much simpler than Upstart was in definition. For that reason alone, I'm actually I'm warming up to systemd. I have warmed up by playing with it. Okay, so that's the targets. If we look at any particular service, let's look at one of those that was stated here. The RPC bind service. Have I got it? Can I find it? RPC bind. Well, it should be here. I'll just look at it rather than scrolling for it. So if I look at the content of our PC bind, ooh. Okay, I've got more than one choice. RPC bind target. You would see that in fact the content is very similar. It's in terms of structure, in terms of syntax, and all it's just saying, okay, it's not got much in it. Doesn't have any binaries in it. Okay, it didn't tell me much more here, but you can see all the purpose of this is to illustrate that the configuration is now, although totally different, is quite readable. And with manual pages, I looked at manual pages, quite good. Manual pages are quite informative and quite comprehensive now. I suppose what I could do with this is just see how we could manipulate that. And one of the things that perhaps I could do, and I would do, I haven't tried it yet, is to switch this run level from 5 to 3 effectively. If you notice, where we are currently, it's just the lib system. So these are effectively templates, for the lack of a better word. The actual configuration is in etc. So if I look at etc, same systemd, and system, in here will be the actual configuration of what's happening. Notice brand new extensions here, and it's that want thing that are interesting here. I'm looking for default. There it is. Default.target is a symbolic link. If I look at the default.target, this is what defines, if you recall, in init tab file, that was the only significant line, still commented out, but telling you how to change the default run level for subsequent boots. And it's the default target that is pointing at graphical target under template directory, lib directory. If I wanted to change it to a different one, I would choose which one. Have we identified what it would be? It would be the target. We had number of run levels there. Run level 3.target. Just list those under lib again. Those that are to do with systemd, systemd, those that are to do with run levels. Okay. Instead of pointing it at graphical target here, if I make it to point at one of the others, run level 3, that would do the job. So run level 3 target. All I need to do in order to affect this is perform a symbolic link. It already exists, so I will enforce it, and the name here is the default .target. I'm not going to reboot the system to prove, because I'm just looking at the clock. We've got 10-15 minutes left, but okay. And of course, I bet most of you are sitting there laughing. You could have seen this coming. She didn't type sudo. At this point, next reboot would bring it to run level 3. If I go back to the slides to see what I've missed, if I've missed, so yeah, that's looking at that link, the target vaguely comparable to run level. We looked at the 2 locations. These 2 locations are significant, the lib systemd, the etc systemd. When you start exploring, please notice that the 2 locations that I visited were directory system within systemd in both of these within etc, indicating that there is an awful lot more to be seen over there, an awful lot more. Hopefully that gave you a good starting point for that. I will move on to the last few aspects of the discussion: instance and system management. We have got now, so that will be just chat about where RHEL are going in those areas. First of all, we've got the OpenLMI software program. That is something that is now available through a repository that you can add to your main repositories. This is where I failed. Interestingly enough, on my system, when I tried to add this repository, installation of the software required me to do the update on the system. And as I said, update for beta wasn't available. So I'm stuck in a vicious circle here. And for that reason, I wasn't able to test it fully. But it's commands that allow you to manipulate and monitor your system. It actually is looking at some of the reviews of that and some of the screenshots. It looks promising. I have no prior experience of this, so I can't comment, other than to know that yes, you can install it, and you can then use LMI as a interactive shell or just a command line for the purpose of managing your machine. We have a big push with Red Hat to go into the cloud, and in fact, the Red Hat now is present very strongly at every level of the layered structure of the cloud services for the platform, for the infrastructure, for the platform, for the software people. They've got their own programs and their own products, and they are. This is. You have a link at the bottom of that screenshot. They allow you to reproduce and download, so I'm not violating copyrights here. But the masses of how many products are available in the cloud are just unbelievable right now. And this is why Red Hat are saying that we should adopt the open hybrid cloud on the basis that all of our IT is currently hybrid. We are using a massive mixture of variety of services provided. And what they're trying to do is their open hybrid program, and I'm sure you'll need to subscribe to that, and the details of that I'm sure will follow as well. But they will have their own version of integrated cloud infrastructure, which will allow you to choose, and I think that's the main point they're trying to make, that will allow you to choose which elements you are selecting, rather than getting tied into a particular vendor, particular technology. their framework will allow you to select the appropriate product for you. And finally, just in the nick of time, a quick discussion about the Linux containers that they are introducing. When we are saying they are introducing, as we'll see in a second, there is very little new in terms of the sentiment. What is new is how modern technology has been utilized to achieve that. I'm not going to go through this too much. This is RHEL 7 preview rather than a history lesson, but just to put it in the context, we have had virtualization or a form of going back to the 60s. And it really is, in a way, a full circle that we are turning right now. Again, without going into detail, we have tons and tons of technology offerings, and we have got different types of virtualization available to us. And this is where the containers are going to fit, is more or less where truth jail is. It is, you can see, OS level. We have got the truth capabilities that we had for decades in Unix. We also have the Solaris zones, and this is where this diagram, by the way, the picture is from one of our standard courses. I have included Red Hat in that. It's a picture rather than diagram. That's why it's missing. But it's in that little gray box at OS level where the Linux containers will fit in. And what it is, it's back to the C groups. It is truth on steroids. It's there for the purpose of being able to separate programs and applications so that they don't see each other. That is for deployment, for mixed, just briefly, mixed AIX RAPs and XUS as well as from OS level. Yeah, that's okay. So there's additional comments there. And we will see the example, the technology that Red Hat are recommending, or particular front-end product they're recommending for the purpose of creating, manipulating containers, and the RHEL will be Docker. We'll see a couple of examples of it later on. Nothing new here. What we've seen, the diagrams that you've seen, we are this time we'll be using for container technology. We are making use of controllers. Those additional kernel parameters must be switched on for that purpose, and the resource allocation limitations and control will be used, as well as ability to do hierarchy. That's interesting. Summary of why containers might do perhaps very well where VMs might reach their limit. So of course, unless you're going for an all-blown, completely VMware-based installation, in terms of the operating system, if you wanted multiple instances of VM containers, being lightweight, because the idea of the container is that you've got one operating system and you separate instances for applications based on processes within that OS rather than adding additional OSs to run with them. So by definition, containers or zones are going to be lightweight and more efficient than a VM, no matter how well organized. So you can have hundreds of them. And you've got the link to read up a bit more. The product that RHEL are going to use for the purpose, Docker, is again, it's going to be an interesting learning exercise for me. I haven't actually worked with it in the past, just looking at it at the moment. It looks very interesting, fantastic website, I must say. So it's a fantastic learning there, loads of tutorials. And I suppose a screenshot of one of their pages, how to run hello world. In other words, how to have one single command. Okay, in this instance, you can see here that's done on Ubuntu. That's their snapshot from their website, hence Ubuntu here. But it's fantastically illustrates what a container is going to be about. That echo command running hello world is going as argument to Docker, is going to create the container, and that container will have its own resources allocated to it, completely independently of the rest of the system. Okay? So that in itself, that screenshot shows how powerful the containers will be, but also, hopefully, with front-end tools such as Docker, how relatively straightforward it's going to be to create one. There is a reference there to the LXC container. That's the kernel level of creating VMs. That looks like it's going to be totally isolated from average sysadmin. So it might be that it's going to be much easier to run than any chroot or anything else. Okay, so that really is all I wanted, and thank you for listening, and thank you for allowing me to introduce that new features of RHEL. As Sam said in the introduction, the session has been recorded, and Sam will make it available to you. We will make it available to you over the next week. There is a techweek@qa.com address now active. Any post-session comments, questions, if you'd like to post there, make sure that you mark for my attention, and I promise to get back to you with that. Other than that, on the right-hand side, I hope you'll print and cut out and build yourself a little tux. And good luck, and thank you for listening. Thank you very much.